This video was brought to you by the ILC. Hello there once again, welcome back. This is episode 49, Writing an Exponential Equation. In this episode we're going to go through a couple of word problems, and I'm going to show you how to build your own exponential equation based on the word problem. Let's have a look at it. Our question this time says, a population of bacteria doubles every 4 hours. If you begin with 1,000 bacteria, how many bacteria are present after 24 hours? To build the equation, we're going to start with a framework. It looks kind of like this. Y equals A times B raised to the power of x divided by t. We have a lot of variables in here, so let's go through what they all mean. The A represents the initial value. If we read the question, it says we begin with 1,000 bacteria. That's going to be our initial value. Now the B represents the base, the number underneath the exponent. The base describes what's happening to the function. Our question says that the population of bacteria doubles. So because it doubles, we'll say that the base is 2 because every time that 4 hours pass, we're doing times 2. We also need to know what the t is. Capital T is how long it takes for that change to take place. The question says that it doubles every 4 hours, so we'll place a 4 for the t. So now our equation should look like this. Y equals A, which is 1,000, times B, which is 2 for the doubling, raised to the power of x over t, which is 4. Let's remind ourselves what y and x are. Y represents the population, and x represents how many hours have passed. Now the question says that 24 hours have actually passed. So our equation will be 1,000 times 2 raised to the 24 divided by 4, which is 1,000 times 2 raised to the 6th power. If you place this into a calculator, you'll get 64,000. And that answers the question. After 24 hours, the population of bacteria will become 64,000, up from 1,000. Let's try another one. A city's population increases by 2% every year. If the city's population is 25,000 in the year 2017, what will the population be in the year 2020? Again, let's start from our framework. Y equals A times B raised to the power of x over t. Remember that A is the initial value. Let's look for that first. So our initial value is 25,000 right now. We'll let that be the initial value. Now B is the base. This time we are not doubling in population. All that we are doing is increasing by 2%. So we're going to start from 100%, and we're going to say since we've increased by 2%, we'll say plus 2%. That makes 102%. Now, when you do an exponential equation, you don't want to write the base in percent form. You want to change to decimal form. So to change from percent to decimal form, we simply move the decimal point over twice to the left, giving us 1.02 as the base. Now for the t. That's how long it takes to make that change. it says that this happens every single year. So we'll let t equal 1. It simply happens once every year. So let's collect all of our terms and rewrite the equation. Y equals 25,000 times 1.02 raised to the x over 1. Let's remind ourselves what x and y are. X is going to be the years that have passed, and y, once again, will be the population. So now all we need to know is the number of years that have passed. It says that we begin in year 2017 and end in the year 2020. So x will be 2020 minus 2017, or 3 years. So we can say our population is going to be 25,000 times 1.02 raised to the 3 over 1. This is the sort of question that you would solve in a calculator. When you put it in a calculator, you should get 26,530.2. We'll go ahead and round this down. Get 26,530 people. And there you go. There are too many variations on this to cover right now, but we'll see more as we continue through the series. Thank you for watching, and I'll see you again next episode.